Okay, amazing. Thank you, Kev, for the introduction. And I'm very happy to be here to speak about a topic that I'm very passionate about, which is how to write the next generation of user interfaces with the Unity and augmented reality, virtual reality in the 3D world, using, as I said, Unity and all the recent stuff like Oculus, VR, etc. So a brief introduction. I am Davide, I'm senior software engineer. I live in London and started working with VR around 2017. Firstly, when I was in Microsoft by producing some small POC with HoloLens, and lately using more consumer-focused devices like Oculus Quest or Rift or HTC VIVE and SteamVR. In the past, I've been awarded 5 years Microsoft MVP for my contribution from the community, as I like sharing my stuff in the blogs on GitHub. And I also like collecting badges, as you can see from these slides. But let's start and look at the content of the session and what I would like to cover this evening. I would like to start a journey from virtual reality by introducing the mixed reality concept, and then moving from virtual reality to augmented reality through a series of steps via firstly introducing some VR development and specifically interaction and locomotion using the SteamVR plugin in Unity. And starting from this virtual reality world, I would like to add more interactivity to this world by the adoption of more natural forms of interactions like vocal commands and hand tracking, and then moving to more AR development with the HoloLens. Let's start by introducing what it is mixed reality. The concept of mixed reality is the blending of two worlds. One world which is the physical world where we live every day, when we can touch things, when we can hear, we can smell, etc. And the other one, the virtual world generated by a PC, composed by bits and bytes. And when you mix together these two types of world, I like to think that it's where the magic happens, because it's when you can augment your world with holograms, or you can check how your house will be with the different furniture, or where you can just pinpoint some virtual screens to your walls and start looking the TV in that way. So sort of a world where the magic happens. To better understand the various devices that you can find for these magical worlds, I found useful this physical digital reality spectrum, which originally I thought was a concept introduced just for marketing purposes. But when I did much more exploration in it, I found out that there was a concept introduced in 1994 in an academic paper by Paul Milgram and Fumio Kishino in a taxonomy of mixed visual displays. And it is particularly interesting because moving in this digital reality spectrum, you can take the two extremes and find one extreme, the digital reality, which is the one completely generated by a personal computer or hardware device. And the physical reality, where you can find devices like the see-through devices, HoloLens or Magic Leap 1 on Unreal Light, etc. So if we follow all this physical digital reality spectrum, we can really categorize all the possible devices that are available for mixed reality. So some devices are completely occluded, like Oculus Rift or Quest 2. One example is this one, if you can see, and if the background remover can show it properly. This is an Oculus Quest, so you can see it's completely occluded devices. You cannot see through on this device. So the reality and the virtual world needs to be completely generated by the hardware, the PC, and by the developer. Some examples are Oculus Rift, Quest 2, HTC VIVE, Cosmos, Valve Index, Windows Mixed Reality, immersive devices, etc. And while we are moving towards the physical reality, we find that these other devices see through, as I mentioned before, like HoloLens and Real Right. And the modality of development, the way for developing in these augmented reality devices is a bit different. You can use the same tooling, but while you need to replace completely and generate a virtual world for Oculus Rift, for instance, you need just to generate some holograms for HoloLens. So you use the same tools, but the modality is a bit different. Why mixed reality? Mixed reality is a sector which is sort of generating a new computing platform, because firstly, we were in the past, we were just working with the 2D user interfaces, and the way of interaction was different. I'm pretty convinced that in the next years, we will start to generate user interfaces in the 3D world, no more in the 2D world. So we will moving towards a new way of computing platform. And there are some studies, like for instance, the one that I mentioned in this slide by Goldman Sachs, that estimate 80 billion revenue by 2025. So there are a lot of economic opportunities. And the mixed reality is already revolutionizing a lot of different sectors. One in particular is gaming. If you think about a virtual reality experience, you need to project on two different screens, one per eye, in order to provide to the user with an immersive experience. So these require hardware which is quite powerful. NVIDIA, RTX, graphics card, 2060, 27, 2080, or the latest generation 3080, for instance, by NVIDIA. And so you need a lot of computing power. Usually, if you are a gamer, you already have a lot of that power in-house, because gaming is clearly quite expensive in terms of resources. And so you can immediately, if you are a gamer, probably have a less barrier to entry compared to other people. And then gaming is a sector clearly where virtual reality is massively used at the moment. But other sectors are particularly getting an exposure to mixed reality. Education is a pretty important one. If you think about the fact that with virtual reality, you can, for instance, train employees and on the job before getting them to do tasks, for instance, manufacturing or HR, onboarding of employees, etc. But other sectors like healthcare are particularly useful for mixed reality scenarios. I was studying recently some papers from universities of London, where there are some studies for visualizing the relation between doctors and patients, or for curing phobias in some other patients. So healthcare is a particular interesting sector for these types of technologies. And we could list a lot of other ones, like real estate. Imagine the possibility of seeing a building in place before this is actually developed. It opened an exciting range of opportunities. Or clearly engineering or military application. Think about flight simulators of training of pilots. These are all possible areas where mixed reality, virtual reality, augmented reality is starting to get traction, and where can really drive a benefit. So how can we develop for AR, VR? We mentioned before that we are probably moving from 2D user interfaces to 3D user interfaces. So if we are developing an experience for virtual reality, we need to provide some different way of designing and developing these experiences. And I found very useful this concept introduced by Professor Mel Slater of University of Barcelona. He categorized a great VR experience having three types of illusion. The first one is the place illusion. Place illusion means that if you are writing a virtual reality game, for instance, like one in a mysterious dungeon, and you don't provide a good environment with the right scale, with the right rooms, sort of mimic the reality of a mysterious dungeon, the user is losing the immersion. So it thinks that is not there. So place illusion is very important. The environment must be well designed, must be in a proper scale in order to guarantee the immersion of the user. And the second type of illusion introduced was the plausibility illusion. The term is a bit strange, but plausibility refers to the fact that if you enter a virtual reality environment and nothing happens, probably you start wondering if this environment is real or not. If you insert in this environment some virtual agents that are directly interacting with you based on your voice or your movement, or you can interact with some objects, clearly you give more immersion for the user, and then you guarantee the plausibility illusion. And the third very important type of illusion for immersing the user is the embodiment illusion. Give a representation of the body of the user in the virtual experience, and in order to guarantee the user the presence of his or her body. And the first experiments that I was doing with embodiment were quite bad. I was trying to represent my full body with my full arms and all that kind of stuff, and that was breaking the illusion in a lot of occasions. Other implementations are one that I really like this one from Oculus, that you can see just by representing the hands and the different position of the hands and the fingers, you already give the user the immersion in the environment, and it's more than sufficient for giving the sense of being present in the experience. And these movements can also be done via the touch controllers, as you can see here, or the new hands tracking in devices like HoloLens or the latest Oculus Quest. Let's see how we can develop virtual reality experience in terms of tooling. In terms of tooling, I think that we can classify three big categories. The first category is the game engine category, where you can find tools like Unity or Unreal Engine 4. Usually these are environments where you can import some assets from 3D software like Maya or Blender, and you can apply some transformation and physics to all these objects in the 3D environment in a very simple way. So usually you can get started very quickly to produce a full virtual reality experience. The second type of environments are the one related to more lower level, so APIs like OpenGL, Microsoft DirectX, or Vulkan, that will require clearly much more development efforts, and will not be quite productive as game engines, but clearly can guarantee a very good performance of your virtual reality experience. And this is particularly important because if you don't produce applications with high frame rates, you give motion sickness to the player, to the user, and then the experience becomes really unusable. So performance is a strong sector where you need to be very careful when designing virtual reality applications. And the third category is WebVR, WebXR. If you are a web developer or a JavaScript developer, you can easily start with these frameworks. Some very notable one are A-Frame or Babylon.js from Microsoft. And they are pretty good framework, but clearly, as I said before, the performance is very important. So probably at the moment, this is the reason why frameworks like Unity or Unreal Engine 4 are getting major love from the design and development of Unity, of virtual reality experiences. In terms of languages, for Unity, C#, .NET, C++ for Unreal Engine, or all the other APIs, and JavaScript for WebVR, WebXR, A-Frame, and Babylon.js. Let's see now how to design a virtual reality experience. As I mentioned before, for designing a virtual reality experience in Unity, in this particular case, we will need to provide a new way to interact. So usually, the important way for interacting in such type of experience are two. The first way is using some VR interactions by pointing, selecting, or grabbing object. This can be done with the touch controllers that are included with the 6 degrees of freedom headset like Oculus Rift or Windows Mixed Reality headset. And the second important characteristic that you need to provide to a virtual reality experience is locomotion, so the possibility of moving to an environment. If you are in a virtual reality experience, try to visit a location or a building, you need to provide the capability for moving into this environment. And you need to provide it in a way to not give motion sickness. So there are some patterns that can be applied, like teleportation, the way of Star Trek, right? I point a specific point in the space and I get teleported over there. And this is quite effective for not giving motion sickness to the users. But other ones like continuous locomotion and continuous movement are quietly well adopted and started to get adopted. Also because users probably start to get comfortable with the VR headset, so you can, in that case, just push a bit the boundaries for locomotion. So let's start with the demo, and let me switch to Unity, and let's see how to create a quick virtual reality app in Unity. I will just use a plugin which is provided by the company that produces the Valve Index, or the original HTC VIVE. The company is Steam. This SDK is particularly useful since it provides a lot of prefab, like the player, or a lot of interaction capabilities for designing teleportation and so on. So usually when you want to get started in Unity with a new project, you just create a new project over there in Unity. And if you want to get started with the virtual reality project, I would recommend to get the 3D standard template, because other types of pipelines like high definition render pipelines or universal render pipeline are supported for virtual reality, but sometimes they cannot work well on some devices. So probably for the safer approach, it's best to get a 3D standard template in Unity. After creating a new project with the template, you get some environment with some asset already available in your environment, so you can play around. So the first step that you need to do for importing the SteamVR plugin is go to the Unity Asset Store and get the plugin from the Asset Store. If you are on Unity 2020.1, like I am now, you need to use the new package manager, which has replaced the Asset Store. So you can get your SteamVR plugin, and you get your SteamVR plugin in the project, and you have immediately available some new folders over there, like this one, SteamVR. You can see in the SteamVR is the container for a lot of prefabs, a lot of scripts that can be used for teleportation or for interaction, etc., etc. The first one, which is very useful, is the player script available in SteamVR. So you can get just the player script from there, which is a prefab technically. And you can drag your player in your scene, and immediately you have all the objects that can provide you with cameras, or if you look at the hierarchy here, over there, the SteamVR objects that are present, you have your left hand, you have your right hand, and so on. So it's already providing everything in place just for having a good mixed reality scene and enabled for headset like Oculus Rift or HTC VIVE. And once you have your player in place, you need to be careful to set the project modality for being compatible with virtual reality projects. And that can be done by selecting File, Build Settings, go to the player settings. In the player settings, you need to select that you are targeting, in my case, OpenVR devices, because I was developing this small demo on a Windows mixed reality headset and Oculus Rift. So if you target OpenVR, you will be able to target all these specific headsets all at once, which is particularly cool. So you don't need to use different SDKs for running the experience on different headsets. And this is using also a new plugin based on OpenXR, which is new standard. It will be replacing the legacy way of doing VR in Unity. And you can find all of this one in the SteamVR GitHub repository. You can find also the OpenXR plugin, which is compatible with OpenVR samples. Once you have initialized OpenVR and XR directly here in the build settings, your apps is nearly ready to get executed for a headset. So if you press play over there, you will be already able to run it in your device. But let's, before look at the demo, before executing the demo, let's see how to add more stuff that we introduced before, like locomotion and interactions. I decided to add an area here in my experience where the users could teleport. So I just created the ground and a Unity 3D plane. And as part of this 3D plane, I added a script, which is called teleport area. So the teleport area script, which is available in the SteamVR SDK, if added to a panel like this, will enable the user to apply teleportation directly in this area. And this is also enabled by two other assets that I usually need to drag into my project. The first one is teleporting. So if I go always here in the search and I search for these prefab, I drag the prefab directly into my experience in my Unity project, I am enabled teleporting. You can see as part of this teleporting, you can customize the different colors for the areas that get highlighted, or highlighting red if an area you cannot teleport over there in that area, and so on. So you can customize a lot of stuff. And that's pretty much it. And you can also teleport to specific locations in your experience. So suppose instead of just wanting the teleport to be enabled in an area, you want just teleport to be enabled in a specific point, just because you want, for instance, your user to start doing a game for a specific location. And you can just use another prefab, which is called teleport point. So the teleport point in SteamVR, here we go, is over there, teleport point. It has this icon. And you can just teleport your experience, and here put a teleport point in this particular location, so I could be near the workbench and interact with the object. So that's the first step for adding locomotion. Just get a teleport area in a specific area of your experience where you want to teleport your user, and you're pretty much done for enabling teleport. Another very important feature that you want to provide to your user is the capability of snap turn. So with the left or right joystick, be able to rotate the camera around in order to see the location and the environment. This is very important to not break the immersion. So I prepared here a small script that can illustrate how to do that. I created this rotate player script, which is deriving from the mono behavior class in Unity. And you can see I have imported valve.vr here, the namespace where all the scripts from SteamVR are located. And I attached this script to the camera, and then in the update method, which is getting executed every frame, I just verify which is the input from the user. And if the input is in the X direction, and it is minus a joystick tolerance that I am setting in order to optimize the experience, I can provide a joystick left method which will execute a rotation of the player on the left, and a joystick right if on the opposite side. For the implementation of these methods, you just need to call the transform rotate method and then apply a rotation on the y-axis for generating this rotation. And this is providing snap turn functionalities for your player. After providing locomotion and snap turn, we want to move to the other important interaction capabilities in your experience, which is either the capability of touch object or move object or throw objects. And to do that is particularly simple in SteamVR, as you can just select an object like this one. Here I have a hat. You can see here I have selected a hat which is on my table. And to add the capabilities for being able to manipulate this hat to the user, you can just add some additional scripts that are available in SteamVR. One is interactable scripts. So with interactable script, just by adding this one directly to the hat, you will be able to touch the hat and start to connect your hat to the hand when there are manipulations and so on. And the other very interesting one is the throwable one. So if you use the throwable one, always available in the script folder, and you attach it to your object over there, you will be able not only to manipulate and collect your objects directly in the scene, but start also to throw that objects in the environment. So let's see this scene. I am using a video that I pre-recorded to avoid bad user experience while doing presentation, but that project is just executing on your headset just by pressing play and having the headset connected. So you can see how we can snap turn in the environment via the rotate script that I showed before. We can teleport in the area that we selected via the teleport script. And if there are some colliders in some objects, you can see the teleport is also not enabled. And we can go to the teleport point that we put near our workbench. And we can start to manipulate the object. We can connect the object to the hands, and we can also throw the object via the throwable script. So just to summarize, we started the blank project. We enabled VR via the build settings, the OpenVR. We added a player object from SteamVR and enabled teleport via teleport area interaction via the interactable script. You really can start developing for VR in such a few minutes. And then I was starting personally experimenting with this stuff, but I was feeling the need to add more natural forms of interaction. So I started developing this small game in a mysterious dungeon to learn more about VR development. And I wanted to provide the capabilities like, okay, I wanted to ask for help, and I just wanted to say help, or I need help, or phrases where the word help is included, and in order to give a more natural way for the user to interact. And so I started investigating, and I found two ways. The first one, the simplest one, is by using the Unity keyword recognizer, and which will enable to recognize very, very simple phrases, but it's working quite well. It's pretty effective for simple requests. And then a more complicated one, like natural language understanding. Suppose that my user is not saying the word help, but then is asking for help in a different with different phrases. And what about using some stuff more machine learning enabled with natural language understanding, recognizing some patterns and training some models, etc., etc. And so that was the second type of experience that I was investigating via cognitive services. But let's start looking at the first one, the simplest one. If you want to use the keyword recognizer in Unity, you can just create a new instance of the keyword recognizer that is available in the Unity APIs, and pass as a constructor a list of strings that you want to get recognized. When one of these strings will be recognized, the onPhrase recognized event will be fired. And then depending on the word that has been recognized, you can, for instance, show a frame per second counter for see how the experience is behaving from a performance point of view. And so this is an example of script that I wrote for enabling a frame per second counter while I was developing the experience. So you usually need to target, when you are on Oculus Rift, 90 frames per second, on Oculus Quest, 72 frames per second, 90 frames per second will be available in the Oculus Quest 2 later next year. But you want to be very careful to reach that performance. So I found very, very useful enabling a show FPS counter by vocal commands. And as this can be done in the recognize on phrase recognized, and then if the word is show FPS, just enable a UI showing the performance of your app. This is perfectly fine if you have very simple commands that you give to your experience. But if you want to recognize natural language, that's a different story. You need to take advantage of some other services, like, for instance, cognitive services, where you can get the intelligent cloud linked to the intelligent edge. So you can recognize some phrases via the microphone or your headset, and then send these phrases to natural language understanding, or LUIS, of Azure, for instance, and see if these phrases contains some events that you want to be recognized, and then trigger some action depending on that. So I did a proof of concept with this, and clearly I started with the Azure portal. I created a language understanding application. After I had created this app, I clearly needed to define some intents that I wanted to be recognized. So one intent that I wanted was providing some help for the user. And I found in cognitive services, this list of intents already predefined. And this is a model that is already trained. So you can provide to the model a lot of simple training phrases. For instance, I want that this event is triggered with the different phrases, also not including the phrase help, like what should I do, for instance. So you can train a lot of different phrases in your model, and then in this way, providing a series of intents that can be recognized. For using this, I implemented a microphone manager class using the dictation recognizer, which is available in Unity. The dictation recognizer is different from the keyword recognizer that we saw before, as the dictation recognizer enables the capture of all the words that the user is saying. So we want to capture a string, which is what has been said in the microphone. We want to get this string, and if the dictation is complete, we just want to send this string to cognitive services, to our LUIS application we defined previously, which is at the end just an HTTP web request call. In this sample, I just used the Unity web request and created the connection to the LUIS endpoint via the query string, which is the one defined and recognized in the microphone. And then you get a response back, which is a JSON. So you just parse this JSON. And if this JSON contains a list of intents that have been recognized, you can do some actions. One action that I did is, if the top scoring intent has a 65% percentage of being recognized as valid, then in that particular case, I can be quite sure that the intent to recognize is good. And so I can, for instance, show an FPS counter as before, or I can just show a help panel for my user. And then I applied this, and I created a small game that is using all the concepts that we just saw right now. So I think the important stuff here in this sample is to understand how when you implement
Can you help me?
teleportation, or when you implement interactions via the interactable scripts that we saw before, we add a bit of voice recognition using the keyword recognizer of LUIS, we can already develop a full working game. And so you see here, I got a bit of fun moving here into my environment, implementing some snap turn to, and then moving into another room and finding some collectibles, and via these collectibles incrementing some score.
Can you help me?
Providing help commands via voice recognition. And then,
show me the score.
Of course, in every dungeon there is a skeleton, and I got that skeleton from the Unity asset store very quickly, so it's not particularly realistic, but it gives the idea. You can grab your stone, you can just kill the skeleton, and that kind of stuff. So that's I think an example of how you can create fully working games just by applying locomotion and interactions and a bit of voice. And when I started running this experience on the headset, I noticed that sometimes the frame per second, the frame rate was not good. So instead of reaching the 90 frames per second, I was reaching 60 or 50 or 40. And then immediately I saw a lot of performance degradation in my experience, and a lot of uncomfortable motion sickness. So I started looking how I can improve the performance of the app. And the one that I found particularly useful is to mark not moving object as static. So you saw in that small video, there were some barrels, some stuff that was not moving. I made sure to mark these not moving object as static to help the batching and the rendering of the scene in the two screen of the virtual reality device. And to do this, clearly I had sometimes to hunt for stuff that was not marked as static. So I found useful to create this script, which is finding all the objects that are marked as static or not marked as static, and show them in my debug log in order to be able to fix them if needed. And the second very important one is the usage of baked lights in virtual reality. If you use real-time lights in Unity, which are enabled by default, you will find a lot of problem with the performance. So one suggestion is just use baked lights if possible, because these will improve a lot the performance of your game. and remove motion sickness. And this one is another particular tips, a very important one. You want to not execute very expensive methods when in the update method of the mono behaviors or while your app is running. So some best practices include caching strings like I did here. So you see here the key tag string is cached as a private variable, so I don't need to create a new string each time that I need to do operation. That's also important. It's a very small detail, but in everything counts in terms of performance, especially in virtual reality. And one important one is the get component method. If you're looking for a component in your hierarchy of objects and you call get component while you're running the experience, this is very degrading performance a lot. And so use it in this way. When instantiate, you awake your scene or your object, just cache the component, and then you can easily call it in the update method, like I did here on the onTriggerEnter method, and then apply some additional stuff. And so these are three very important characteristics that I found useful while developing for virtual reality. And then let's start moving towards the other part of the spectrum, so versus the augmented reality part, and see how devices like Oculus Quest are enabling capabilities that previously were available only for devices like HoloLens, more expensive devices. And if you use Oculus Quest, you can have full hand tracking, which means you can use potentially the device without touch controllers. And you can have full fingers mapping and full finger tracking, manipulate objects and everything. And this is a particular cool feature, in my opinion, because you can start really to move into the blending of the two digital worlds. This project is particularly useful and interesting, has been particularly interesting, at least for me, which is the mixed reality toolkit, which is clearly used for developing application for HoloLens and Windows mixed reality devices, but it's working also to all the other devices like OpenVR supported, like Oculus or HTC, etc., etc. And if you recently downloaded this project, especially in the last weeks, you found in version 2.5 the latest implementation of the extension for Oculus Quest that were created by community members. And this enables the usage of Oculus Quest with the mixed reality toolkit. And the mixed reality toolkit is a fantastic tool for having hand manipulations, hand interactions with virtual objects. And so I showed here a small sample of the scene which is available with the mixed reality toolkit. You see, you can also play pianos. Probably, I don't think it's a very good idea playing piano, at least for now, in virtual reality, but you can see how the hands tracking and the finger tracking can also enable that kind of experience. And then you can do manipulation like this in HoloLens, do style of scrolling of information, and also interact with object at distance via sort of this laser, which is starting from your hand and is capturing and interacting with the collider of the various Unity object, interaction with the buttons, like you see right now, and these one that are particularly cool in my opinion, which are the two-handed manipulatable scripts, which is called Object Manipulator, Mixed Reality Toolkit. And imagine the scenario where you want to provide the user the capability of visiting models or exploring some objects in detail. this is a fantastic manipulation gesture that we want to implement in your application. And these are the capabilities of the mixed reality toolkit, and we are starting moving versus development not only for virtual reality, but also for augmented reality, as mixed reality toolkit enables experiences both in virtual reality, but also in augmented reality. And I remember when I was in Microsoft, was do some experiment with the HoloLens. Clearly, the first experiments that I would call the hello world for augmented reality is capturing some images from the camera and sending these images to cognitive services for computer vision and recognize what it is in your environment. And let's imagine the future when devices like this one, HoloLens, that have a lot of sensors, depth cameras, and eye tracking or hand tracking. And when these sort of devices will be miniaturized, will be built into normal glasses like the one that I'm wearing now. And this will enable a lot of experiences. And let's think for visually impaired people, for instance, how this can be really useful for these scenarios. And so I started this first experience, hello world, capture a photo from the camera, send the photo to the cognitive services, get it recognized, and show it on a HoloLens. And I started clearly by the computer vision API, like we did before for language understanding. You can use the computer vision and create an endpoint in computer vision. And then I connected this computer vision endpoint with some NuGet packages initially for a UWP app that I wanted to not to move immediately to HoloLens, but just to create a small application UWP to see that, to check that the API were working. And then I got my NuGet package connecting to the cognitive services. I got the capture from the camera and send the camera to the cognitive services. And then I was getting back this JSON that was enabling me to analyze the picture were captured from the camera. And that's all good, but then I said, how can I put this into my HoloLens device? And I decided to create a small DLL that was the one used by my UWP app. I imported my DLL in a Unity project that I created via the mixed reality version toolkit in 2017. It was called Holo Toolkit in that period. And I just added a small status text and detected some voice commands from the HoloLens using keyword recognizer sort of stuff, but implemented with the Holo Toolkit. And then I sent this image to the
analyzing picture
to the cloud.
A flat screen television.
And see, you can see here when you can start to put together voice, image capture, image recognition, and all in the form factor of the HoloLens. And I think the results were quite good because in terms of recognition of visual objects, the quality from communicating services was very, 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 very good. And you can move to another generation of services now. Suppose if you want to do remote rendering of big scenes when you have millions of polygons, you don't really have the performance in mobile devices or in desktop device to render such quantity of polygons. If you think a device like Oculus Rift or HTC VIVE, desktop VR usually can handle a couple of millions of polygons, and you have scenes, especially for I don't know, analyzing virtual cities or virtual buildings, etc., that can easily, for photogrammetry, that they can easily have 150 million polygons. So that's something that you cannot really do on the devices that we have nowadays. And so you need to create some alternative solutions. One can be remote rendering from Azure. So mixed reality services provide this remote rendering. So you have these big GPUs running in Azure that render the scenes in the cloud, and then when they render the scene in the cloud, they send those directly to these mobile devices like HoloLens or any virtual reality headset. And this is probably an area that will be much more development in the future, as remote rendering is particularly interesting. But other services like spatial anchors look very, very promising for mixed reality application. And this is the capability to add anchors for specific location into the world space. So pinpoint object for training purposes, for instance, or for visiting cities, or for doing, or for buying stuff in a supermarket. That could be a lot of application regarding spatial anchors. And this is using a combination of services, machine learning, computer vision, etc., etc. And this will be very, very important to be embedded with augmented reality experiences like HoloLens. Object anchors, if you want to anchor object directly to a player, for instance, or a specific object in your scene. So to summarize what we went through this evening, we started from the concept of mixed reality, and then we moved how to develop a virtual reality experience. So we started moving from the spectrum, from the digital reality spectrum, developing for virtual reality, and we moved towards the augmented reality side of things by adding additional interaction using voice and some performance about consideration about performance, and the latest toolkits like mixed reality toolkit using hand tracking and the mixed reality services. And my key takeaways when working with this technology is check performance early often. So as much as you have done a big chunk of optimization of your unit scene locally, just try immediately as soon as possible on the device, because then it's when you start looking at the correct scaling, the performance, if you're looking right, and a lot of other stuff. And there is really no substitution for testing your virtual reality experience into the device. Test frequently and design properly the experience. Remember the types of illusion that I mentioned before: the place illusion, the plausibility illusion, and the embodiment illusion are very important if you wanted to write a virtual reality application. And if you wanted to take the experience to the next level, use cloud service to enhance it via speech, vision, or anchors, which is very, very important. And I would like to leave with a phrase by Arthur C. Clarke, Profile of the Future, that any sufficiently advanced technology is indistinguishable from magic, because when you try this stuff, it's really magic. And thank you very much. And the slides are available online in my site. And I'm here for any questions, if there are any.